Now we need to talk about the acid-base properties of salts. And two things to think about when you're figuring out the acid-base properties of salts. And the first we already just talked about. The conjugate of something strong sucks. So what we were saying earlier is that something like bromide, that is a non-existent base. Why does bromide suck at being a base? Well, because bromide is the conjugate base of a strong acid, and the conjugate of something strong sucks. Same thing here. Potassium sucks. Why does potassium suck at being an acid? It is the conjugate acid of strong base. That is not a good acid at all. So, there are 5 crappy bases and 12 crappy acids. And by crappy, I mean non-existent, right? Your crappy bases are chloride, bromide, iodide, nitrate, and perchlorate. Those are all crappy bases. And then your crappy acids, they're going to be, if you grab a periodic table, and I feel like I have one somewhere. Here we go. If you grab a periodic table, your crappy acids go down through the family. Lithium, cation, sodium cation, potassium cation, rubidium cation, cesium cation, and the francium cation. And then the other crappy ones are going to be alkalines. So beryllium, magnesium, calcium, strontium, barium, and radium. Super crappy acids. So what does this mean? Well, the first kind of salt that I want to teach you about is a neutral salt. And neutral salts, these are salts that will not change the pH. So when they dissolve, the pH doesn't change. The pH stays equal to 7. They're neutral, right? They keep the water neutral. That's why they're neutral salt. And a neutral salt, ladies and gentlemen, contains one of these crappy acid cations and one of these crappy base anions. So you do the math. It's like that SAT question, right? Where you got like 12 shirts and 5 pairs of pants. How many outfits can you wear? The answer is 60, okay, right? There are 60 neutral salts. You pick one from here and one from here, you got yourself a neutral salt. So what's a neutral salt? Well, sodium chloride. That would be an example. Pick another one. Awesome. Potassium iodide. Yup. If I dissolve potassium iodide in water, the pH stays 7. Let's get a little more complicated. Let's take an alkaline metal. Strontium. Wonderful. Pick one for nitrate. I love it. Strontium nitrate. Neutral salt. Let's do another one. How about calcium? How about perchlorate? I love it. Calcium, perchlorate, neutral salt. Rubidium bromide, neutral salt. Those are your 7 neutral salts, folks. Or I'm sorry, those are your 6. These are, what do you got? 1, 2, 3, 4, 5 examples of the 60 possible neutral salts, right? You go down through them all. But they all there. Yeah. Any questions on neutral salts? Neutral salts. You got to memorize the 6 strong acids. If you memorize the 6 strong acids, you can remember these 5 conjugate bases. Remember, sulfuric acid doesn't count. That one's special. It's actually diprotic. And then you just need to remember that group 1 and group 2 metal hydroxides are strong. So the group 1 metal and group 2 metal cations are crappy acids. Okay. How are we feeling about neutral salts? Okay, let's do, I don't know, let's do Man, it doesn't matter to me. Let's do basic salts next. Here we go. Basic salts. These increase the pH of a solution when they dissolve. So the pH goes up, hence basic. And these guys are going to contain an alkali or alkaline earth metal, so a crappy acid cation. So that's going to be an alkali or alkaline earth metal cation. And the conjugate base of a weak acid. So basic salt is going to contain an alkali or alkaline earth metal cation and the conjugate base of a weak acid. So let's look at some examples. That's going to be something like you pick sodium, great. And then we're going to pair that with the conjugate base of a weak acid. So for example, a weak acid would be something like acetic acid. So what's its weak base? What's its conjugate base? Acetate. So sodium acetate is a basic salt. If you dissolve sodium acetate in water, the pH is going to go up. Let's pick another example. How about calcium fluoride? That's a basic salt. Why is it a basic salt? Well, the calcium has no impact on the calcium has no impact on the pH, but fluoride is the conjugate base of the weak acid HF. So fluoride is a decent base. That fluoride anion is going to act basic. Absolutely. I mean, we could pick, a bunch of other examples, So something like potassium formate. Now, you don't even know what that is, but here's how you know this is basic, right? It's got potassium, so it's not acidic at all. And this is not one of those five. And if it ain't one of those five, that is a basic anion. That's the formate anion. Formic acid. Oops. That's a weak acid. I know it's a weak acid because it's not one of the 6 strong acids. So that means formate is a decent base. And yeah, it's going to be a basic salt. Okay. All right. Questions on basic salts. So if you contain an alkali or alkaline earth metal cation, and you contain the conjugate base of a weak acid, so some conjugate base that's not chloride, bromide, iodide, or nitrate or perchlorate, you're going to be a basic salt. You're going to make the pH go up. Okay. And then finally, we got, as you could probably guess, acidic salts to cover here. Acidic salts, as you probably guessed, decrease the pH. They make it acidic. They are going to contain a crappy base. And the conjugate acid of a weak base. Because the conjugate of something weak is decent. Conjugate of something strong is non-existent. The conjugate of something weak, decent. So for example, how about ammonium chloride? Ammonium, NH4 plus 1, that's the conjugate acid of the weak base ammonia. Ammonium is the conjugate acid of the weak base ammonia. So it's actually a decent acid. The conjugate of something weak is decent. Fluoride, no impact on the base. So that's going to be a decent acid. We could pick another one. So how about methyl ammonium? So if we did, oh, whoa, somebody just, no, I don't know what sound that was on my computer. If we did CH3NH2Br, that's the methyl ammonium bromide. Methyl ammonium bromide, okay, bromide, crappy base, not going to affect the pH. This is not an alkali or alkaline earth metal cation. It must be decently acidic. If I dissolved methyl ammonium bromide in water, the pH would decrease and go down. Now there is a final type of weak acid salt, and that is a salt that contains a hypervalent cation. No, I feel like it just keeps going and going and going. So file this under your acidic salt thing. I just ran out of room. So hypervalent cations are also acidic. What does it mean to be hypervalent? A charge of +3 or greater. The two most common hypervalent cations are aluminum +3 and iron +3. So for example, aluminum nitrate, that would be an acidic salt. I will explain why hypervalent cations are acidic in just a second. It's actually pretty complicated. Iron +3 whatever, FeBr3, that would also be an acidic salt. How are hypervalent cations acidic? So like aluminum bromide, how is that acidic? Here's what scientists have figured out happens. Why do these decrease the pH? These hypervalent cations, since they have a large positive charge, they suck a lot of waters around them. In fact, most of them form these octahedral ion dipole complex ions in solution. And what happens is this by donating, because you got a +3 charge here. Oh, there we go. When you have a large magnitude charge, the oxygens donate a lot of their electron density to try and stabilize that. And what that means is that these oxygens are actually pretty upset because oxygen is really electronegative and it doesn't want to donate its electron density to these hypervalent cations. So what happens then, scientists have figured out, is a seventh, and they actually have this arrow backwards, a seventh water molecule will come in and steal a hydrogen off of it to make your H3O+. You get your hydronium ion here. And notice this hydrogen is gone. Okay, so my charge has gone from +3 to +2, and I have my hydronium ion. So what happens here is, pretty complex, where we get this octahedral thing going on. You don't really need to know any of that. What I need you to memorize is that +3 cations and greater, when you pair them with chloride, bromide, iodide, nitrate, or perchlorate, you'll make an acidic salt. Okay.